Small logistic issues. So hello, good morning everyone. Happy to have you all here. So thank you, Alex, for introducing the accelerator. I think it's a good case, a good discussion that we have. If you remember, during the first 2 days, we have discussed about a lot of things. Technologies, dual market, commercialization. I think everyone here is interested about commercialization, at least I hope that, and about money, how we generate money. We have heard the first panel session this morning. I remember the presentation from Pascal Rodel, very interesting, talking about horizontal verticals that Alex just reminds right now. It's very important that during that session, we'll have different startups. They will share their use cases, their business cases, more than a use case, and how they will potentially generate revenue in the future. And I think they could be the right candidate for the future accelerator and for our panelists which are present here, which I'd like to thank very much for assessing those startups. I would like to introduce first Miss Estelle Godard, if I'm pronouncing well, sorry, from Promus Ventures, deep tech and space tech investor. Miss, maybe you can just jump, say hi so that people... Miss Marie Nicode, sorry if I'm pronouncing bad, from Expansion, who is investor director. Mr. David Dana, from the European Investment Fund, head of VC investment. So that will be the challenge for you all to pitch, to see your projects in front of those very important persons, especially in that deep tech and space tech sector. So I will invite the first project, which comes from Poland, recently established an entity in Luxembourg, doing autonomous space rovers. Mr. Philip, please come on board. Applause to Philip.
Thank you very much.
You have 10 minutes to impress the jury members.
Okay. Hello, everyone. Thank you for the opportunity to present ourselves. Is this? Okay, sorry. Okay. So I'm here to present to you the company 4Point. You might remember us from last year. We had a very cute rover that was driving around Space Resources Weeks 2023. But this year, I want to show you a more broad aspects of what 4Point is. And just to remind you, the 4Point was established in Poland in 2018, and 4Point Space was established last year in Luxembourg with support of ESRIC Startup Support Program. So what is the opportunity that we're exploring? Well, we believe that currently the transition that our economy is undergoing is primarily resource related, and there are multiple technologies that require additional resources that are just not available, including electronics, automotive, and also the green transition towards the renewable resources. And let's quantify this opportunity. So we can focus on 3 examples here: copper, lithium, cobalt, minerals that are crucial for development of products. And as you can see on those graphs, the predicted requirement for usage of those resources is going to grow significantly in the upcoming years. And in red, you can see operating current mines that are extracting the resources. They're not growing, they're even falling down. And the current constructed plants are nowhere near being able to fulfill the demand. So what is the problem here? You could think that old exploration methods are capable of filling this demand, but that's not the case because they are very labor intensive and success rate is extremely low. This is because the exploration is largely manual, conducted by a team of experts, and it's inefficient, prone to unpredictability. So to put it in numbers, more than 99% of exploration projects ever fail to become an operating mine. And nowadays, mine operators are spending way more time and resources than even 30 years ago to establish an operating mine. Why is that? To put it very simply, the easy discoveries has already been done, which means that currently the resource seekers need to drill deeper and harder, which is contributing to the increased cost and time. This is where we come in. We have a 3-pronged approach where we want to support mining operators in prospecting, later in exploration projects, and finally when the mine is operating with transportation. So we have our 3 products that work together. And I will start with TerraEye, which is our main development right now. This is a web-based platform that allows users to have access data from multiple sources that our proprietary algorithms are combining and processing for them to create a data catalog which can be queried based on on-demand requests. And we believe this data should be easily accessible. Therefore, our platform is available through the web. Therefore, you don't need your own computing resources. But we are also able to produce easily accessible reports. So just to sum up, we are using multiple data sources. The insights provided by the platform are easy to understand, and they're directly actionable, and they are fueled by our proprietary software. We are working with partners that are already interested in the concept, and we are developing proof of concept projects with them. So we created the database based on geological reports, samples collected also by our team, satellite imagery and scientific literature, which is now powering the Terra-I technology. Based on our estimates, we believe we can speed up the prospecting and exploration projects up to 5 years, reduce significantly the cost up to 20%, and later on, when the mine is built and operating, reduce the monitoring cost by 50%. And now you might think, okay, but how can we be sure that this technology works? And this is because we do extensive validation. Here on this slide, you can see on the left side a ground truth map from a well-known region in Nevada where copper exploration has been extensively tested. And in the middle, you can see the state-of-the-art results of cuprite's search compared to what our software is able to produce. So we are even better than state-of-the-art with way less computational resources. Here now you can see an example of how the process data looks like for the user. It presents in an easy and approachable ways detection and also the predicted deposit sites. And let's put now numbers onto it. We have about 96% accuracy for copper detection, 92% accuracy for nickel detection, better, 20% better than state-of-the-art for bare earth crust, and for 13% better for MTMF methods. Now, once you establish the mine, this is not where our application ends. We can help you to monitor the mine. Our engineers couldn't help themselves to try other things you can do with satellite imagery. So now we have capability to monitor ground movements, to monitor ongoing mining activities from day to day, and for example, also to look at water resources or foliage. And now this technology is applied to Earth, but we hope with upcoming projects to try to apply it to the moon to fuel the in-situ resource utilization for future colonies. Now, what is the market response to our offer? As you can see, our funnel is still pretty narrow, but we already have commercial contracts, and we only hope to grow in the upcoming months. I believe that we are at the moment where our small snowball is starting to roll faster and faster and grow to a significant size. And now, to support our prospecting data platform, we are developing an autonomous vehicle that would aid a team of geologists in exploration projects on site. It's going to be capable of utilizing drones and advanced advanced local data acquisition methods to support in situ data processing without the necessity to send the samples to the lab, even further decreasing the processing time and exploration projects time. This is all still fueled in the back with the Terra-I platform, which is going to provide the first estimates of where the mineral deposits are located, and the vehicle will remain in contact with the platform to perform as best as possible. And now, let's say a few years past, the exploration project was successful and the mine is operating. This is where our product that you might remember comes in. This is the autonomous transfer platform. On the bottom left of this slide, you see the cute little robot that we've been operating last year. It has been developed in collaboration with ESRIC through the Startup Support Program. In the few short months that the project has been running, we successfully developed the navigation software based on machine learning algorithms. And we believe in further developing this product to really become a player in the transportation market, both for Earth and for the moon. And for the lunar application, we are now partnered with Astroport for the lunar landing pad projects, where 4Point is responsible for providing a concept for a regolith exploration. So we know this is not the aspect of the business that is gonna bring income anytime soon, but we're looking towards the future and remembering our dream to reach for the stars. And just to sum up, a few words about the company. So in the past, we've received multiple grants and we've been awarded contracts with commercial partners, both for commercial projects and proof of concept projects. And in the upcoming years, we plan to grow our sales team, develop further capabilities of the platform to look for additional minerals than the ones I already mentioned, and even expand our offer with the data marketplace that could bring other players in remote observation to our platform. So thank you very much for this opportunity. I would very much like to invite you to our stand upstairs, where I am able to provide you with a demo of our platform. And yeah, now, thank you. I'm open for questions.
Thank you very much, Philip. So maybe 1 or 2 questions briefly. The time, maybe the good question that will help our jury members assess better 4Point Space in Luxembourg. Any question? Anyone wants to invest? Yes, please.
So this is entirely based on the type of analysis you want to do and on the area, but we're estimating the base price of about 50,000 euros per exploration project, with on top on that costs per kilometer squared. We want to operate it as a software as a service, so the pricing will be flexible and really tuned to the particular application of a customer. So what area you want to have analyzed and what type of analysis you want to have run on this area.
Last question, Suleiman.
How will you ensure that the collected data is correct? And will there be a cost for collecting that data?
So we are using ground samples currently to provide ground truth for our analysis. This is the validation data. And at some point, we believe that what comes out from our algorithms is true. But no one is going to build a mine just based on the findings from the platform. So after finding the potential candidates for mine sites, the next steps will always be to send a team with geologists to do some drilling. But just the scope of the drilling will be much limited because you will already know where to do it.
Thank you.
Yeah.
Oh, yeah. Definitely.
Sorry, I didn't know if you had to ask questions or not. But which part of your business do you expect to generate the most revenues?
Sorry. So currently we see that the prospecting, the Terra-I platform is our main driving sales point. And with the rovers being on the back burner, this is something we're going to develop when we secure the cash flow and the stating of the company. So the remote sensing part, essentially.
Maybe in terms of financing, so how much do you need? What are the financial needs and where will they bring you to in terms of development and maturity to potentially get customer traction?
So currently we are in the seed funding round where we're seeking to secure 2.5 million euros for the current round.
Another question maybe by Marie, it's okay. So thank you very much, Philip. Thanks for your presentation. Big applause. So the next project, it's from Czech Republic, started also here in Luxembourg via the ESRIC program. So having a laser-induced breakdown spectroscopy, having a market for terrestrial application, and having a deep project for space applications. Please allow me to welcome Ina here.
Thank you very much, ladies and gentlemen. So today I'm going to present the ISRA payload, which is in situ resources analyzer. And it's work based on the LIBS technology, laser-induced breakdown spectroscopy. Just in simple words to imagine how it works. So we shoot the laser creates some kind of microablation, it shines, and we collect these photons with the spectral camera and analyzing the spectra, and then comparing to the database and saying, okay, here is oxygen, lithium, and so on and so on. It has quite a broad implementation, and I will try to put the story from space to ground. To imagine where we are in the value chain, we are in prospecting, and this is how the future should look like. We imagine it like this. So about the technology, the main advantage is that you can basically do it remotely. You don't need to prepare the sample. You just shoot on the spot, and then the analysis takes really fast moment. And just to, let's say, represent it, you can come to our booth. We have a breadboard model, which basically is working. And you detect the elements quite quickly. The payload which we are developing for the rover should fit into the size mentioned here, and should weigh less than 2 kilograms and take, for the operations, less than 30 watts of power. And this payload should be also not only for the moon. The moon is, let's say, the moon is actually more challenging than the Mars. And it should also serve for different types of missions, commercial missions and scientific missions. Actually, what is interesting is that Europe never sent so far LIBS payload. There were LIBS payloads sent by China, by US, by Indian Space Agency to the moon and to Mars. There are several scientific groups working on a LIBS payload in Europe, but nothing was sent yet. And we are the first company worldwide who is commercially able to sell this technology. In terms of, let's say, terrestrial use, I just point 2 cases. One is the mining industry, where you basically do the analysis on spot and understand the composition. You can do the mapping, you can do several points and very quickly get the data, what can you mine. And another example is the industry for recycling. For example, in the plastic, you can put it on the conveyor belt and analyze the heavy metals in the plastic, which is recycled. In terms of timeline, the terrestrial one, I think the prototype is there. It should be tuned, and it can be ready, let's say, next year. In terms of the space one, it's more challenging, and it will take several years because maturation of the technology, which can work basically in space in a miniaturized version, is quite challenging. So you can find us under this address. Thank you very much.
Thank you very much, Ina. Thank you very much. We can use this mic for questions. Any question? Thank you.
Thank you. Yes, you may have said this already, but how deeply below the surface can you analyze things?
Yeah, it's also actually quite an advantage. It's a semi-destructive method. So basically, when you shoot the laser, you can imagine that basically you destroy a little bit the surface. And you can do it several times, so you can basically take the first layer up to 1 millimeter.
Thank you.
Thank you very much for your presentation. I found your concept very, very interesting. Have you actually considered it looking at the IC programs, space challenges?
Yes, it's just the beginning, but we are I listened, and it's very interesting. From your presentation, actually, I have an idea for recycling the satellites, because then if you melt the whole satellite, and then you can check what is there and how you can basically use this material for printing, for example.
Excellent. So I don't need to ask any questions. Thank you.
One more question.
Yes.
Okay. You mentioned about detecting metals inside of plastic on conveyor belts. It seems to be a real world case instead of the moon projects. And I guess that is the real value to improve your business. How can you detect the metal inside of the plastics, and how fast can you detect? Because if there's a detection, that machine should separate the metallic part in very short time. So your system should detect it in very short time.
Very fast. You can check it upstairs. It works quite fast, and the rate of the sampling and the analysis, it's matching the conveyor belt speed.
I guess that is the selling point. Thank you.
I have a question from Mary.
So your customers, are they the, for instance, the mining or resource companies,
these
or the robot companies? And in that way, what's your market size?
So basically we are just exploring, because I gave only 2 examples of the industries, but there are many more. We are actually also exploring the construction industry, like checking the bridge state. So it's, for a moment, I don't have like the full number, but just taking into account the mining industry and, let's say, plastic industry or recycling industry, the numbers are quite large.
Can you name some of the main terrestrial competitors at the moment? Like, who are other players that are currently working on that and that are established?
I can't tell the name of the companies directly. There are several research groups working on a similar technology, but in terms of the companies who are able to provide it, I don't have any name. I don't know if maybe my colleague have. No?
Yeah, for laboratory use, there are multiple companies, and for in situ analysis on terrestrial applications, there is also some competition, but there is also some added value from our system, especially in terms of data processing and existing data libraries that we have. So there are some other selling points that we can just also discuss later on which we can base our strategy. Yeah.
Any other last question, maybe? So, thank you. Thank you very much. So the third project to pitch, coming from Turkey, if I'm not wrong. So we see the globalization of space resources. So please allow me to welcome from Sira Space, Ms. Gurur Gaye Gunal, to explain their project regarding space debris recycling. Please, a big applause.
Okay, thank you very much. Thank you very much all for sparing your next 10 minutes to listen our project. Our project is about establishing Space Debris Recycling Center, which is a kind of innovative and out-of-the-borders project for now. In this project, our main target is following huge collaborations with all the companies who can contribute in our designed Space Debris Recycling Center. Now I will bring you a kind of futuristic journey with the video and animations that I'll show you. And you will easily see that our target is being a pioneering member in this industry with this project. We are saying that if you want to be the light to the world, you have to dare to do something which no one has ever done, and you should not stop until you're proud of what you have done. This is our target and roadmap. You can see that our project name is Carina Project. We are planning to design fully robotic and autonomous space station where we can recycle and refurbish inactive space debris and also satellites. As you see, according to the Space Environment Report 2023, there is already 16,990 satellites in orbit, and 2,500 of them are inactive satellites. And still up to now, there are not any alternative solutions to reuse or recycle these satellites in orbit. So our project will be a kind of game changer in this field. As you see, this impact of the satellites are so serious, and they are big threats for the current active satellites. And also, according to the Wikipedia records, there has been 36 incidents which has been occurred because of this inactive space debris, and more than 600 crash in orbit. And the alternative solutions are about burning these debris in atmosphere, which is causing additional, more small particle debris, and same as the laser technology solution, satellite retrievals or recycling these inactive debris, satellites or debris on Earth are the alternative solutions. But most of them are not that cost effective, and the others are generating more small particle debris, which will be so difficult to clean them afterwards. Our principle in this project is no competition, just collaboration. There are a lot of industry members who can contribute in this project, as its size is quite huge. And under this principle, we signed 25 MOUs with the experts, university professors, and leading companies in this field for realizing this project. Our solution is about capturing this inactive space debris with the help of the electromagnetic nets, which we have strengthened with the neodymium magnets. And on top of the magnet, we will use octopus robotic arms to let it open on top of the item that we plan to capture. And after, the mechanism will close itself and drag it back into station. In the first unit, I want to... Oops. Can you help me to make video work, please?
Which one is it?
Next one.
Next one.
Next one. Next. This. Yeah, thank you so much. About this space station, it occurs from 6 top units and 3 beneath, and it will provide us to use orbital move. We plan to establish it in LEO, in 400 kilometers height. First, initially, we plan to clean LEO debris, and after GEO. Here in the first section, after we capture and grab that inactive satellites into space station, we will scan and analyze the structure of the debris that we have captured. And after, in the second part, we will transfer it to another detailed scanning department. In the third part, we will make the separation and we will break it into pieces, and we will send it to melting furnaces, and after 3D printers, which will provide us an opportunity to print more equipments in space. And then we will send them, if we will refurbish, we will send them to solar panel repairment units, or maybe battery refilling or fuel refilling unit. And then we will be able to deorbit it from the station. And the platform is not rigid, its shape can change. As you see, these are the units of the station which we will use. And the market size, it's around $5,076,000,000 space industry value up to 2023 records. And in this project, it will be possible to recycle or refurbish these inactive satellites. And it will give us a lot of opportunities. Instead of other member states to try to develop these technologies by themselves and spend a lot of money for creating their own solutions in it, we invite them to collaborate in this project all together and share piece of cake all together, because there are enough piece of cake for everyone to share in this project. And also this center, as it will be in the LEO, it can also serve for ISS as a backup center, and also for the active satellites for refilling their batteries and fuels or repairing their solar panels. It can be another alternative. So this will be a kind of space fabric in LEO initially, and after, if it works well, we can also launch it to GEO for the other satellites. Regarding its robotic part, I want to introduce you my colleague, Professor Dr. Miguel Olivares Mendez. So he will present you the robotic parts. Thank you.
Thank you very much. Hello, so my name is Miguel Olivares. I'm professor at the University of Luxembourg and space robotics and the head of the Space Robotics Research Group. So I'm supporting the initiative of my colleague Guran in a way that robots, of course, are needed for having this system operative, because we cannot rely on human doing all this work. And of course, it's not working? Okay, well, I can continue. Yeah. So, of course, the idea is to have a fully automated system. So having the possibility of robots to going from one unit to another unit in order to make this whole process of disassembly, then separating parts, selecting what parts are important, or be on the right status in order to be reused, and also do the full assembly. So we are currently doing this kind of research at my research group at the University of Luxembourg, and we have a ground facility where we are testing some of these specific activities. As you can see in the video, the conceptual idea is to have the different units in where different activities are done, and then robots can be reutilized in different units, going from one place to another. So.
I may add something. There will be a magnetic rail system which will allow us to move robots from one unit to another. And as you see, all systems will be fully autonomous, and we will connect them to each other with the pipes that we will use. And regarding realizing these parts of the project, we already signed the MOUs with related companies who are already working in its field. And of course, we need to develop some part of the project. And probably we plan to launch our project in 2029 by completing all the R&D parts, prototyping and manufacturing types. Thank you very much for listening. Thank you.
Thank you very much. Maybe if I can start with the first question. I'm starting to be a little bit familiar with the recycling business, and someone, you will have the next question. I am the first. I'm privileged a little bit. It's good that we discuss a little bit about the competition as well, because there are some competitors which are present here. Just to be sure and to understand properly, are you providing the full supply chain of your products, or just some pieces of technology, And do you want, the second question being, the operator of all of that at the same time?
We plan to build a huge consortium regarding realizing this project with the partnerships who we already agreed on to let them in to contribute it. And we will organize, we prepare the ingredients to make a cake and we design the recipe. So we are telling them to share the piece of cake all together and let's cook and eat it. So there is the cooking part and eating part left, and I believe that we can do all together. And in previous presentations, I've seen more future collaboration candidates for us to contribute in it. So we don't see any of our colleagues in the industry as our competitors, because there is enough piece of cake for everyone to take a project like this. In the future, it can be also a kind of intergovernmental project, especially regarding the ITU's allocation rights. So it has so many octopus legs and different aspects to contribute in. It's a huge, but we believe that we can do all together. I hope you believe in too.
Thank you. The question just here, please.
Okay, so I wanted to say that thank you for your presentation, because I have a short story to tell you that when I submitted my publication on space wreckage and the use of the removal of space debris, the editor for the publication told me that my ideas of recycling space objects into spare parts for space objects or even materials for construction of space objects are absurd and mostly science fiction, and nobody in the field of space law and space sciences discusses this. Okay, so my question is, have you considered the legal aspects and contractual aspects of such operations of dismantling and recycling, upcycling dead space objects?
We already thought about the legal aspect of it. As you know, it's a debatable subject regarding the ownership situation of these inactive satellites and space debris, whether they are abandoned property or not, do we need the owner's consent or not. But in this regard, as we are asking owners to recycle or refurbish at the beginning of the transaction before we start, and just because they do not have any other solution regarding this. And on the other side, there is a stick of United Nations, which they show countries to clean their space debris. Up to now, there may not be any serious sanction regarding this issue, but we believe that if we can provide technical solutions and provide our services to clean up, recycle, and refurbish this debris, then the other consents can easily providable. And regarding recycling and refurbishing, we plan win-and-win business plan, which means that when we recycle the raw material of the products, we will deduct the total amount of the raw material from the service price that we will provide to the owners of the satellites. So it will be a kind of win-and-win and cost-effective for the owners of the satellites, and there will not be any concern. Especially, we will provide a secured and encrypted software communication channel for the owners to let them upgrade their software system in their satellites if they decide to refurbish and deorbit it from station to space. So all of them are unique and new subjects that we are bringing in front, but everything starts like this. If we repeat ourselves, we cannot proceed. So even if, for someone, even if it sounds like a science fiction, all science fiction movies are becoming real in one day, so it is possible. We only check if it's feasible or not, and as we sign our MOUs with the related contributors in this field, we obviously see that it is feasible. So there's no prevention on it.
Thank you. Thank you very much.
How do you plan to execute your fundraising roadmap for the project?
We've created some alternative financial solutions regarding this. As a Sira Space, we registered first space money currency of the universe as an NFT form. And we plan to sell them in an open auction for industry members with a special white paper, which we will provide them a kind of bonus income over the income of the project. And we will provide them a kind of opportunity to take place in this project and to have some benefit over the income of it. Everything is so innovative in this project, so we should have designed something unique in its financial side too, to not to be binding with the funding issues and the others.
Very interesting presentation. I find it real challenge you have taken. I'm glad to see you looking at in-space recycling, so I would assume you'll be looking at our call. Question, International Space Station, you mentioned it. Yes. What do you have in mind? Recycling, how is it going to be related to your concept?
Yeah, for example, there has been a crack in space station's window in the previous years regarding the space debris, which is smaller than 1 centimeter, and it's been cost them too much to repair that glass and do all that launchings and sending the technicians there, etc., whatever it is. So we are thinking that if there can be any need regarding the raw materials that we have converted to the equipments which we can use in space stations, we can provide it from this space station, because there will be already some storage where we have converted raw materials with the help of 3D printers, and which allows us to print some materials that we can use in space stations and satellites. So it can be a kind of backup place.
And what is the TRL level of your concept now at the moment?
We are about to complete our R&D. We've been working on this 1.5 years regarding its research for building the collaborations regarding this. There are already current technologies that we can implement in it, and we don't need to scratch the island from the beginning. There is already something.
For sure, between TRL 1 and 4, I guess.
Yeah.
Thank you.
Thank you very much.
One question again about the financing aspect, because it seems interesting in principle, but concretely speaking, it's quite cost intensive to develop all those technologies first and then to bring them to space and to start recycling from space.
Yes.
How do you see the feasibility of it and under which time frame?
Yeah. As I mentioned earlier, we spoke to the experts and leading firms who are already working in this field, like 3D printing companies, like melting furnace producers who are planning to implement their technologies in space field and who has already have developed technologies regarding that. And according to all that meetings that we made, all these things that we showed you in this animation are feasible and possible to do it, because there are already developed technologies with that companies and the experts. And the only necessary thing for us to implement these technologies in one main project by uniting all of them together.
Thank you very much.
Thank you.
So maybe a final point. I think it's a very highly capital-intensive project, and as there is a big pie to share, I invite everyone to discuss, and mainly to see potential competitors here. I invite you to discuss with Frank Koch. They had a similar project as well, as the project might be significantly challenging. So thank you very much for responding to the questions.
Thanks a lot. Thank you.
So the fourth project, not yet the final, will be from Germany. I would like to invite Alex Looking, sorry for the pronunciation, from FibreCoatings, who will present their project having fiber coatings for terrestrial markets and potential use cases as well for the space market. Thank you very much.
First of all, I have to apologize, because you will hear very, very little about space and moon in my presentation. we have asked ourselves the question whether we can afford living in a world which is connected. Connected means like our mobile phones are connected with the Wi-Fi, our cars are connected. For some of us, even our fridges are connected. And all those things are interfering with each other. That means if you're at home and you see 100 different Wi-Fis, those Wi-Fis are slowing down your Wi-Fi tremendously. And we see this as a huge disadvantage. The shielding market, you might never heard about, is 100 billion US dollar huge. It is from cars, like in EVs, the battery and frequency converter needs to be shielded, otherwise sensors for autonomous driving would not work, pacemaker would not work, or your mobile phone would not work, and you would not accept that in a car. But also, military is a huge thing about EMI shielding if you want to talk and discuss things privately without the enemy listening to you. But also, our mobile phones are full of shielding materials. This is even more important, the shielding material, if you look at the mega trends at the moment, which are supply chain and resources crisis, the EV market I already mentioned, or 5G and also upcoming 6G. So we will be even more and more and more connected. There are solutions on the market to solve all this with metal fibers and metal textiles in order to shape something around a device to shield it properly. But those materials are 300 to 600 US dollar per kg. So they're not really affordable if you think you need 10 to 20 kg in a car. Only Ferrari and Porsche can afford some of those materials. At FibreCoat, we came up with a completely new solution. We produce a material, a basalt fiber, which is similar to the stone on the lunar surface, which is melted at 1,200 degrees Celsius, and then coated very little with aluminum at speeds of 1.5 kilometers a minute. This leads us to the possibility that we can sell those materials for $30 to $60 per kg, depends on the fiber of the fiber thickness and composition. Our price advantage comes from, as I mentioned, the speed, but also because we are narrowing down 10 process steps to produce those fibers to only one process step, as I showed in the production here, or what you can see in our booth in the main hall. But also our energy consumption is way less than producing pure metal fibers. This is how our materials look like. So this is a fiber coming directly from our production. And those fibers can be processed into very kind of textiles, like you can see also on the slide. So each kind of textile, for example, you're wearing, can be processed from our fibers. Our aluminum coating technology has different markets. I already mentioned the EMI shielding for EVs. But there's also heating elements can be done from this material very cheap. Filter, design elements in cars, but also for the moon, those materials are super important to prevent from dust, as this is one of the major problems on the moon. We are a team of 18 full-time employees, and we are quite proud that we have more than 15 different cultural backgrounds in our company. We started with 3 founders 3 years ago, but now we are growing and growing, and we are here today to raise also money to double the size of our company from 18 to 36 employees. To give you a perspective how our business model so far looks like, you see all those little dots on the map, and all those little dots are fiber manufacturing companies all over the world. And we are going there and enable them with our patented technology to produce those fibers exclusively for us. This leads to low capex, on-demand production, and we are extremely supplier independent. At the moment, we call it our headquarters. We are a small startup, but we call it our headquarters, which is located in Aachen, in Germany. But we have also production sites in Sangerhausen, which is in eastern Germany, in Gorlice in Poland, and in Rostavi, which is in the country of Georgia. And we have a sales office in Houston in Texas for the US market. The IP I already talked a little bit about. It is completely owned by us. We brought the IP which we developed at the university. We brought it from the university. And in the meantime, we also developed 2 new patents, which are partly granted in Germany, in Europe, and in the US. In the past 2 years, we've done 1.2 to 1.5 million US dollar in revenue. And in this year, we have a forecast of 4.5 million in revenue. So you can see already a little bit of the hockey stick. At the moment, we are doing direct sales. So we're letting produce the fibers, and we sell directly. However, with our partners who are producing those fibers, we are already negotiating complete licensing deals so that we can, in the future, focusing on new technologies. So we are here to raise another 10 million US dollar, as we already raised 4.4 million US dollar 3 years ago. It's our Series B in order to build our own production in Germany for the German market and extend our current businesses. We are the building blocks for an affordable future, and we are happy to answer all your questions. Thank you very much.
Thank you very much. Any question?
Yes, please.
So I'm just curious, when it comes to the shielding performance, if you compare it with the metallic fibers that you presented at the beginning, that you will be replacing, how do you perform compared to them?
It is the same material, so those metallic fibers are also from aluminum. Our coatings are from the same aluminum, so the shielding performance is the same.
Okay, because even the basalt fibers.
The basalt is not shielding at all, but we have the same amount of aluminum in our fibers, like the aluminum fibers you can purchase on the market today. It has the same shielding effectiveness.
Okay, so basically what you offer is that it's way cheaper to produce, yeah.
Exactly,
okay.
yeah.
Thank you.
Thanks.
Another question? Thank you.
Hello. Yeah, I have a small question. So at the start, you talked about Wi-Fi performance, right? Right now, as of 5G and even previous generations, we have many working bands, around 10 on regular internet. 5G has even more working bands, so that connections don't interfere with each other. The idea would be to coat apartments and buildings in FibreCoat to prevent signal escape for security, or what is the market purpose here?
Yeah, as our materials are cheap and affordable, you can think of it as a wallpaper. So you can have the beautiful flower on top of it, whatever you have at home, but we are an interlayer. And if you have it in the outside, on the walls, for example, on your flat, you're not blocking all Wi-Fi's from your neighbors, but 80%. And this has a direct effect on your Wi-Fi. The same is for doctor rooms. If you're in an MRI machine, and this is a problem a few doctors approach us with, if you're in an MRI machine and there's a 5G antenna close by, those MRI machines are not working properly. So you have to shield those rooms. And if you have to and retrofit them, it's super easy to do with the wallpaper. You and I can also bring on the wall, and not a fancy company you have to pay a lot of money for, and with materials which are also extremely expensive. So this is those are the markets we see for the 5G and the Wi-Fi shielding.
Thank you. Maybe a final question here. Yes.
Thank you. My favorite question, what's your TRL level of your technology?
Okay. We are producing...
Concrete answer, right?
Yeah, sure. TRL 9, because we are producing 10 tons of the material I presented to you each month, and we are selling them too. So it's a tier 9. Yeah.
Thank you for the precision.
Last one. Regarding your production in other partners, how do you protect your IP and be sure that you keep ahead of competitors, especially working for different kind of use case and, for instance, defense and so on?
As I mentioned, we have the patents partly granted already. It takes more time to have them all granted. But in the end of the day, I think the patent is just having the foot in the door with the fiber manufacturer to tell them, hey, you can't copy us, but they can, right, if they want. So everyone who's interested in working with us, and we have 3 already, with them we have quite clear contracts. And in the contracts you can define the terms very well, way better than you can do in every patent. So this is how we are protected.
Thank you. Thank you very much. Thanks
Thank you very much
for the presentation. We are running a little bit out of time, so I will try to make it faster. So I would like to invite Pascal Koch from Imensus, here, data mining data providers. Thank you very much. From Germany again, just to mention, so we are a little bit overrepresented by German colleagues. Thank you. Big applause to them.
Okay. So first of all, thank you very much for this great opportunity to present our company here at this conference. But before we speak about our company, I want to show you some challenges you as our future customers might have. Because the success of your ISRU mission depends heavily on preliminary geological exploration. Why is that? Because we can answer urgent questions like how much volume is within your future license area, and if there is the required amount of volume, can you mine the regolith without any issues? I'm speaking here about buried boulders, fractures, or gaps within your license area. And can you reach the planned location for extraction safely? Imagine you want to mine regolith within the crater. You have to drive safely downward the crater rim. And last but not least, only geological preliminary exploration can answer the question how deep, for example, anchoring of landing platforms has to be to stabilize your infrastructure projects on the regolith.
So consequently, our future customers will be space agencies, research institutions, and you, the ISRU companies. To address these challenges stated by Pascal in the beginning, we aim to develop an autonomous rover capable of doing seismic surveying. Seismic surveying is a widely used resource exploration technique here on Earth, and we want to bring it up to the moon for you. So our setup will consist out of 3 units. First, vibrational sensors, we call them lunar phones. These are deployed into the lunar surface via a feeder mechanism. This feeder mechanism will also be able to retrieve the lunar phones for further surveys. And then the rover has an implemented vibrational source. The source generates seismic waves which propagates through the subsurface and get reflected as well as refracted at layer boundaries and obstacles. And with the arrival times from the sensors, we can calculate a geological model. So our system enables us to do fast exploration with high resolution for a greater planning security.
So our services span along the whole ISRU project chain, but the most important part is the site investigation and the resource estimation. If we want to collaborate in this segment, we have 4 steps of collaboration. First of all, we will develop an exploration strategy based on your specific inquiry. Second, there's the on-site exploration completely done by Imensus with our rover. The data and the geological model we will send to your customer graphical user interface, and of course we will evaluate this data together with you. So our product is the data, not the rover.
Yeah, right now Imensus consists out of a geoscience department and an intellectual property department with Pascal Koch and me, Olaf Cornelius. Then we have our 3 aerospace engineers, Abhishek Anil, Diego Solis, and Juan de Freitas. So as you can see, Imensus is a multidisciplinary startup with geoscience and aerospace engineering, which is outstanding in the startup world. And this enables us to realize our mission and drive commercialization forward. Based on the lunar market assessment study by PricewaterhouseCoopers, the space industry market is growing rapidly. We estimate that the market volume of our data acquisition services will be $4.7 billion. And by the way, Imensus was named as one of the top promising lunar startups in Germany by the Manager magazine.
So we are working together since a couple of years as a student project. But in January, we did the next step and established our company. In March, we start with our first public funding program, the ESA Business Incubation Program. And in April, we will start with our second public funding program, the Validation Fund of the University of Kiel. Together with these two public fundings, we will develop the first component, the lunar phone. And afterwards, we have multiple steps of development. And at the end of this decade, we will fly the proof of concept mission to the moon. Of course, what we need is a clear transmission of the space technology into terrestrial application, and we will do this by an active patenting and licensing strategy. So what we need is now money from you from the first round of private financing. And we speak about 30 million euros we need in the next six years in total to cover the business operation expenses as well as the research and development expenses and the active patent and exploitation strategy. And on the right side, you can see the current distribution of shares in our company. So Imensus aims to become one of the pioneering geoscientific service provider on the moon for you.
Our data, your success. So.
One single question, please. Who wants to address it? Do you remember first? You have one?
The signal source that you guys are utilizing, is it an acoustic source?
Yes, kind of so. Acoustic waves are pretty much seismic waves, but in fluids or gas. So if they're in solids, you call them seismic waves. So basically, yes.
Have you done any analysis on the effect of vacuum using those acoustic sources?
To the moment, not, but as you know, maybe most of the Apollo missions already done seismic experiments, so there's also already a lot of data regarding this topic.
Okay.
Yeah.
Thank you.
Here. Do you plan, on your development roadmap, do you plan to use the first product you will develop to market them on Earth or for other applications to fulfill your requirement for CapEx and financing, for instance?
Yes, so currently during the development we are looking into the market, doing patent researches and market researches for other companies which are developing geophones and exploration equipment, for example for the hydrocarbon industry here on Earth. And what we aim for is to patent really key parts of the development, not a whole system, so key parts, and then offer these key parts for active licensing by this company. Then we get a license agreement or a license contract, and this spans through an entire span, maybe of the lifetime of the patent, up to 20 years. And so we have more planning, stable planning for income. So it will not cover the whole cost of the projects, of course. So we need additional funding, but it should cover a part of the research and development progress. Yeah.
Thank you. Thank you very much. Thank you for presentation.
Okay.
I will now invite from Norway, far away, the CEO, Itel Tolentino, who has focus on mining in industry, but also specialization in the technology in the beneficiation. She will tell us more about that. Thank you very much. Welcome, Itel.
Hello. Before I start, I want to thank ESRIC for their support during the pre-incubation phase and for the opportunity to pitch to you today. SolsysMining is all about beneficiation. The process of refining, oh, is my slide on? Yes. Raw materials by separating particles based on their properties, like particle size, density, mineralogical, and elemental composition. These steps allows us to extract valuable elements and minerals from ore, ensuring the quality and concentration needed for the following ISRU applications. After 2 insightful days at Space Resources Week, we continue to acknowledge the central challenges in space exploration, its limited resource availability, and becoming as self-sufficient as possible. Overall, we need to develop our capabilities to rely less on resources on Earth and more on what we can produce and extract on the Moon. But it's not just about extraction, it's also about finding ways to do it responsibly. And and this also applies for Earth, of course. We do that by optimizing extraction efficiency and yield, enabling reuse, repurposing, and finding use cases for byproducts and waste. Our beneficiation technology contributes to solving these challenges, but beneficiation in space is in itself a challenge. We call it the black box of beneficiation, a complex system where the inner workings aren't fully defined. This picture is from one of our earliest presentations. It's an example of how the terrestrial mining industry has emphasized the complexity of beneficiation, while in the space realm, it's still to some degree oversimplified to processing. Our advantage is the team's real-world mining or minerals processing experience in the industry, where the intricacies of beneficiation are deeply understood. For space, we approach the black box with the precision that it in reality really demands. Essentially, beneficiation is an enabling technology. It's the steps between excavation and end product. By processing lunar regolith, even scarce resources can be economically feasible and our customers' operations more profitable. We can optimize resource extraction efficiency, screen for the appropriate particle size for 3D printing, and SolsysMining is focusing on extracting elements and minerals for plant fertilizer, as well as processing byproducts and waste, as this can be valuable to other customers. One company's trash can be another company's treasure, or you could say we can create several revenue streams from the same material. SolsysMining operates within 3 of 7 fields in the space resources value chain. So by leveraging synergies and opportunities, we enhance the value proposition for organizations that are engaged in ISRU. So how are we planning to deliver this technology to our customers? Our ESA-OSA project, Project ELISA, is a proof of concept study which gained significant media attention. It made it possible for us to promote our technology and our company, and also open doors for collaborations. We have proven that beneficiation technologies, if adapted to the specific requirements of regolith, will indeed increase extraction efficiency, and in some cases, by a factor of 10. We have also developed and tested methods for removing toxins like iron. It's toxic for plants. Going from lab to market, the ESRIC pre-incubation phase provided the tools and support to advance our business and technology development efforts. It revealed several synergies, particularly within ESRIC. A great example is the ground-based pilot plant, which highlights our team's expertise in beneficiation and also in pilot plant design, which is a rare alignment, to say the least. The Norwegian Geotechnical Institute, or NGI, has been valuable to us due to their expertise in geotechnical engineering, as well as expertise in soil and rock mechanics. Our collaboration with Lightigo Space for characterization services is a very promising endeavor, as data collection is central to beneficiation. And there are also very strong synergies between SolsysMining and LIST. Another testament to how we leverage synergy is our new or near-term product, Lunar, which is a next-generation lunar regolith simulant. Lunar is a spin-along co-developed with our space beneficiation technology. It's consistent, it's competitively priced, it's easily available, and most important, it's processed and produced in a novel and sustainable way using Norwegian resources. And at the same time, we are adhering to the current Norwegian mineral strategy and aligning with the circular economy. Lunar is developed in collaboration with NGI. It's funded by the Norwegian Space Agency. It will be ready for market next year, and the estimated financial projection looks promising. 3 things I want you to remember from this pitch is beneficiation is a critical enabling technology for ISRU. Our team's extensive experience and expertise not only enabled us to prove our concept in the lab, but also positions us to be successful in R&D in the future. And lastly, the vast potential for synergies. Thank you for listening, and please come see us. We'd love to answer all your questions and have a chat. Thank you.
Thank you very much, Itel. One question, one single question. I think everyone understood. Perfect.
Okay.
No question. Thank you very much. So let's jump on the second. Thank you, Itel. For the before the last one, coming from US, from Colorado, yes, Orbital Mining Corporation. Ken, Chris.
Well, good afternoon. Hi, my name is Chris Tolton, and I'm a graduate student at the Colorado School of Mines. I'm also a co-founder here with Ken of the Orbital Mining Corporation, and I want to at least initially thank both ESRIC and the Colorado School of Mines because they paid for 2 plane tickets. So a lot of us came from a long way. We have 2 Colombian students here who came with us as well. Anyways, today, let me give you just a quick background about the company. We formed actually after winning the NASA Watts of the Moon competition back in 2022. And today's presentation, we're just going to give you a little bit of an overview of the company and then also talk about our commercialization plans. Just to start out, our mission, our long-term mission is to mine the moon by the end of the decade. It's something that's kind of aspirational right now, but it's something we take very seriously. Next slide. Okay, so why mine the moon? Lots of good reasons to mine the moon, and I think a lot of folks in the audience already know the answer to that, but I'll start. Number 1, of course, lunar regolith is largely made out of oxygen. Number 2, we have multiple data points suggesting that there's water ice in the polar regions. And number 3, it's a lot easier from an energy perspective to get from the moon to the Earth than vice versa. And the 4th reason is because we think that there's going to be a big booming rocket fuel business on the moon by the end of the decade. And we think that's going to be very critical to the colonization of Mars and any sort of operations in cislunar space. Okay, so mining the moon, not easy. Why? Because, of course, mining is very power intensive. I think it was a Portuguese guy here I was talking to, a grad student, and Australia, for example, uses as much energy as Portugal does in a year. So very power intensive. There's lots of other environmental issues with mining on the moon, which many of you guys already know. High radiation, vacuum, very low temperatures, down to like negative 180 Celsius, which is pretty much cold enough to break anything. So what we're saying is, without developing some energy infrastructure, we're not going to have any sort of industrial scale mining of the moon. Our solution, of course, is a small microgrid. I think initially it's going to be a DC microgrid with lots of cables. It's going to be hybrid. It's going to integrate multiple sources of power, so think not only solar but also nuclear. And it's also going to be able to, it's going to have to be able to integrate other forms of energy storage. So think also, big batteries, but also fuel cells. It's got to be available pretty much all the time, and it's going to have to get through the lunar night.
Yeah. Hello? Oh, go ahead. Okay. Yeah, so reliability is the key on the moon. So the rovers right now cannot operate on the during the lunar night because there's no solar power, there's no heating elements that are easily accessible without radioisotopes. So what our system will allow you is to recharge your rover during the night. So instead of waiting for 5 days or 14 days for electricity from the solar panels, you can recharge with us. You can also bring more payload mass with your system when you have reliable energy available with our power grid. And we believe this will kickstart mining and enable permanence on the lunar surface and really kickstart the economy there. We're a prize-funded startup from Colorado School of Mines, and we've won about $700,000 from NASA for all of our competitions in the past year and a half, and we've used that money to work on our hardware. So our hardware, this is the NRFD system. It enables you to actually survive in cryogenic vacuum without using any active heating or cooling elements. And this is a microgrid that we hope will one day fly to the moon. So we know that it's going to cost a lot of money and it's going to take a lot of time to actually get a return on investment for a real lunar power grid, something large scale. This is true for any infrastructure projects. So we think that dual market is very important for our survival and our strategy. Our first product is actually a 2 kilowatt DC converter, which we use in our microgrid, but we think will be very useful for electric aviation. Right now, the electric aviation market is moving to the 800-volt battery architecture, but currently all of the avionics do not operate at this voltage. And our DC converter can actually go from 800 volts down to the voltage that avionics operate at. So we think we're perfect for this niche. And then we would expand after that. You've heard from Chris and myself, and then we also have a genius hardware engineer who's ex-principal engineer from National Instruments. And thank you, and happy to take your questions.
Thank you. Thank you very much. Chris, Ken, thanks a lot. One question. Jury members eventually. They're busy ratings, analyzing. Maybe I can ask a question to the jury members. Do you feel comfortable understanding the topics, highly disruptive, innovative technologies? Does it enter in new standards by what you used to see globally? Or is it maybe too disruptive technologies to assess? We can discuss that later on. Any question?
Yeah, here. Could you tell a bit about technology development? On what technology readiness level are you currently?
I would say we're at TRL 3-ish, maybe 4. So we've proven that we can operate everything in vacuum. We've operated in very cold temperatures, not quite to cryogenic yet, but that's about as good as you can get on the Earth.
Thank you.
Thank you for the pitch. I think the dual market application is important indeed. I was just wondering, what's your value proposition with regards to existing solutions on Earth, and how do you compare to other players that are already on the market?
Yeah, so I don't want to name like a specific competitor, but we've actually used their product before. We're about half the weight, similar size, and just 1% more efficient. So for comparison, it's like 97% versus 96%. And we think that we can, win with this kind of value proposition.
Temperature as well.
Oh, and we have better temperature range, obviously.
Thank you. Thank you very much.
Okay.
Thank you for a pitch, for a great presentation. And maybe the final one before lunch, because we all wait for that. Sorry, a little bit for the delay. Please welcome Dimitri Goldenberg from Spain, presenting his project Spacebackend.
Where's the screen? Hello, everyone. First of all, the timer on the screen creating a lot of stress, but I guess if we will not resolve the operational gaps in the lunar industry and the lunar exploration, we all will have a lot of stress. Spacebackend is going to digitize the lunar infrastructure, Because ISRU, it's not only about prospecting, excavation, processing of the materials, it's also about operations, automation, and remote maintenance to reduce the time, human exposure, and associated risk. And for doing it, we first of all need to resolve the current operational gaps, and this is exactly what we are doing at Spacebackend here. We are resolving the highest pain in payload connectivity, control management, and remote maintenance for payload owners, platform owners, and of course, mission operators. We have identified 3 main issues. The first one, this is the payload integration. Today, platform companies, it can be lunar lander companies, LEO satellite companies, spending years in the manpower to integrate the different type of the payloads to their platforms. They're dealing with a lot of incompatibility issues and spending many months to integrate every payload by developing a custom software. The second issue, this is the payload accessibility. Payload owners don't have the direct access to their payloads. They are forced to use emails, big files, to request to operate their assets. And it's not in real time, it's not user-centric. And the last issue, this is payload scalability. Today, every payload we are developing and going to deliver to the moon, to the LEO, to another places, we need to develop a custom software to handle, to process different telecommands, telemetry, to operate, to automate this payload, because every device is different, every hardware is different, and the requirements are different. And if we want to establish a sustainable lunar exploration and resource extraction in the near future, the operations and payload integrations cannot be done anymore in this way. So for resolving these problems, we are developing AI-driven framework for enabling seamless payload integration, connectivity, management, and operations for any type of the connected payloads. Actually, this is a cloud platform that enabling cloud platform that reducing the development time, reduces expenses, and provides an easy way to configure the desired instrument, then automatically generate 3 different layers of the software solution. First of all, I should say this is solely a software solution. We are basing on the application layer, and we are generating 3 layers. The first one, this is the generic payload driver. After the custom configuration, we are compiling a specific driver for the payload, and this driver is empowering any type of the payload with remote control intelligence and onboard automation. The next layer, this is the Space-B sync, and maybe one of the most important for the platform companies. This is a software layer interacting with the flight software to enable modular payload connectivity. It's reducing, in average, 6 months per payload for integrations. And the third layer, this is the payload operation software for remote monitoring, maintenance, data analytics, and remote support of the connected devices. I think the most important for the lunar economy is that our approach is allowing us to resolve the current lunar operational gaps by providing one artificial intelligence engine that is able to empower all connected devices with the most critical capabilities addressed by the leading space agencies around the world. The first one, this is capability to operate in a no connectivity. The additional capability, this is a predictive maintenance for actuators, for sensors, and even detecting anomaly effects in the different components of the devices. And the goal-oriented operations. Our market is scalable. It's including about 200 missions we are expecting to support in the lunar application starting from 2026. The same solution is also resolving the same operational problems for the LEO companies. We have hundreds of satellites orbiting the Earth. We have about 500 payloads delivered to the LEO for microgravity researches, for in-orbit manufacturing and construction. Also, we have terrestrial applications. We can discuss about it later. But now the most important, before my time is finished, I would like to talk about the actual business. We're creating an impact by reducing about 250,000 per satellite in the payload integration. For the lander companies, we are reducing about $500,000 up to €1.5 million euro per payload integrations. We're reducing 1 to 2 years in the software development to integrate between platforms and different payloads. We're reducing more than 20% on the software assurance qualification. We're reducing more than 1 year for the payload owners on development of the custom software for their payload controllers. And we're enabling one AI that can support multiple types of the instruments. Regarding our roadmap, we are going to publish the basic MVP product in 1 year under requirements of the signed LOI letters. Then we are going to use 1.5 years for commercialization and scale. Let's make the impact together, the next impact together. One of the reasons also we are here today is because we are looking also for the private investors, for design partners to support the MVP development, and also to increase our team in our next steps. Our next goal is to convert 5 signed letter of intentions and MOU with well-known companies to the first commercial contracts within the next 12 months. Thank you.
Thank you, Dmitry. One final question. Yes, please.
Thank you. Do you have examples of corporates or other companies in the space sector that have tried to develop this internally and that had to go to other suppliers for either one software competitor or several ones?
Actually, the industry is going to this direction to enable interoperability between different assets to make the operations more agile, but mostly the current companies on the market, they are focusing to resolve these issues, but for the satellite operations, more in the flight dynamics, and there's less solutions on the market for the payload operations, and there's less companies that are trying to resolve the payload integration issues. More questions?
I think it was perfectly clear, and Stomach is speaking here. So thank you very much for everyone. Thank you to the jury members. Very appreciate your help here. So one important point before going to lunch, I know you are very hurried with that. We'll announce the winner, because there is always a kind of competition, at 5 p.m. upstairs. So enjoy your session. Good luck to the jury members, assessment, and thank you for the startups presenting your projects. Enjoy your meal. Thank you.